All right, lesson 1.3 is solving linear equations. So real quick, let's go ahead and take a look at some rules for solving equations. When you solve equations, you have two rules that you need to follow. First of all the variables must be on one side of the equation. Doesn't matter if they put them on the right side or the left side, but the basic rule is they have to be put on one side. And then the other rule is that anything that's not a variable needs to be placed on the other side. Okay. The second rule is whatever you do to one side of the equation, you must do to the other side. So if you subtract 3, for example, to one side, then whatever's on the other side of that equal sign, you need to subtract 3 on that side also. Okay. So let's go ahead and let's take a look at some examples, some just basic solving equations that you've seen for a while. So the first example is x plus 3 equals 8. So go ahead and pause the video at this time, solve these four, and when you're done, go ahead and restart the video. Alright, so let's take a look at this first one, x plus 3 equals 8. So one thing I always do is that equal sign works as a divider. Okay, so remember we've already got our x's on one side, so in this case I want to go ahead and subtract 3. Okay, now remember, whatever I do on one side of that equal sign, I have to do the exact same thing on the other side of that equal sign. So since I minus 3 on the left side, I'm going to minus 3 on the right side. Positive 3 and negative 3 cancel, so x equals, and 8 minus 3 gives me a 5. And I can plug it in and find out, yeah, 5 plus 3 gives me 8. Okay, when there's no sign between them, that means to multiply, and the opposite of that is to divide. Well, if I divide the left side by 2, I'm going to divide the right side by 2. So m equals negative 3. Okay. Let's go ahead and do this one on the bottom. M over 3 equals 5. Well, this bar here, anytime you see that bar, means to divide. So we're going to multiply to get rid of it. So m equals, if I multiply the left side by 3, I'm going to do the right side by 3. So m equals 15. Okay. So the next one, negative m plus 8 equals negative 16. So if we have this boundary, the first thing is our variables are all on one side, so I'm going to subtract 8 to get rid of it. So I get a negative m equals a negative 24. Well, there's an invisible 1 here, so there's a couple ways you can do it. I can change it automatically to a positive m, but if I change the positive or the left side to change its sign, then I got to do the other side. And technically, what allows me to do that is to divide by a negative 1. So m equals a negative 24 divided by a negative 1 is positive 24. Okay? Alright, so let's take a look at when we have items that, first of all, the first rule is, remember, we need the variable to be on one side. So in this case, yeah, the variable's already on the left side of this equation. So sometimes it helps when you're given problems like this that to circle the variable and find out, okay, what is not part of that? Because technically right now I have two x's. And so the first thing is I have a minus 3. So I need to get rid of that minus 3 by adding 3 to both sides. So a negative 3 and a positive 3 cancel each other out. I bring down everything that I've not done. So I bring down the 2x, I bring down the equal sign. This side I can take 7 plus 3, which gives me 10. And then on the other side, now I'm back to what I had before. Remember, 2x. So I'm just going to divide by 2, and I find out x equals 5. Okay. All right, so the next problem is a u-try. So go ahead and pause the video, and I want you to do 4x plus 7 equals 27. Alright, so when we're solving these, remember this acts as a divider. Here's my variable, so the first thing I'm going to do is subtract 7. So 4x equals 27 minus 7 gives me 20, and then I divide by 4. So x equals 5. Okay. All right, next problem. We can work these with decimals. Decimals they're going to work exactly like they would if these were whole numbers. Okay. So the first thing is, here's my variable. I have 0.2 x's, And then I'm just simply going to add 8. Add 8. Remember, line up your decimal points when we're adding decimals. So I get 0.2x equals 8.6. And this just means to multiply, so then I'm going to divide. Divide by 0.2. So x equals 8.6 divided by 0.2 gives me an answer of 43. Okay. Now some of the problems that you're going to have, all the problems we've been working on so far, the variable has been on one side. And now we're going to be working with problems where the variable could end up on both sides. Well, you just got to remember that first rule is the variables need to go on one side. Now, it doesn't matter if you move the 6 or if you move the 2, but bottom line is they have to be placed on one side. I usually use the rule of subtracting the smallest one, and because my ultimate goal is to see if I can avoid some negatives. So in this case, since 2x is smaller, I got to get rid of it on the right side. But whenever I do to one side, I've got to do the exact same thing on the other side. So I'm going to match up. So 6x minus 2x gives me 4x. I haven't done anything to the negative 4, so it has to stay. A positive 2x and a negative 2x go away, and I bring down the 10. Now I'm left with a problem exactly like I had the one before. So the 4x has to stay, and I got to get rid of everything else that's not part of the x's. So I'm just going to add 4. So those go away, and I get 4x equals 10 plus 4 gives me 14, and then I divide by 4. So x equals 14 over 4 can be simplified, and I can simplify it to 7 over 2. If you reduced it to a decimal and left it 3.5, there's nothing wrong with that. Fractional answers are the actual best answer that you could give. Okay. All right, the next one's a U-try, so go ahead and pause the video and see if you can do this one. All right, so let's go ahead and take a look at this one. M minus 30 equals 6 minus 2m. I'm going to do the exact same thing, but I have a positive and a negative 2m. So on this side, I'm going to add 2m. So I get 3m minus 30 equals 6. And again, it turns out to be just like the one I had before. So I add 30, add 30. So I get 3m equals 36, and divide by 3. So m equals 12 is your answer. Okay. Now here, the greatest thing about these problems are basically we just keep adding a little bit each time when we do this. So in case of this one, first of all, I now have parentheses. So remember, we learned this in the last unit that anytime you have parentheses, we just need to distribute. And you're going to have to make sure and take care of everything on the left side. So 2 times x gives me 2x. 2 times 2 gives me 4. And I do the same thing over here. 3 times x gives me 3x. 3 times negative 8 gives me negative 24. Okay? And now the problem is exactly like the problem I had before. So first of all, I'm going to get rid of the smallest x, and this is a great problem to show you that I can subtract this 2x. But remember, if I do it on the left side, I'm going to do it on the right side. So those go away, cancel, and everything else I'm just going to copy down. So 4, 3x minus 2x gives me x minus 24. And the only thing I have left on this side is a minus 24, so I'm going to add 24 because I got to get rid of everything that's on the same side as the x. So 28 equals x, or x equals 28. Okay. All right, the next example is we're going to solve 8x minus 6 times the quantity x plus 4 equals negative 18. Now there's a couple things here that we need to take care of. Before we can do anything, we do already have our x's on one side. But we need to get all of that consolidated and condensed down to everything that looks alike and is alike down to the single one, so we can start solving it. Because you'll find out that once you start cleaning these problems up, that they'll end up exactly like the problems we had earlier. Okay. Now I will caution you that this negative here has to go with the 6. So the 8x isn't multiplied times anything, so we're just going to bring it down. The negative 6 times x gives me negative 6x. Negative 6 times a positive 4 is going to give me a negative 24. And it's very, very important, and everything else just gets copied down. It is very, very important that when you distribute it, that negative sign is in front of the x so it has to be carried throughout. Okay. Another general rule that I take into consideration is when you're looking at the left side, make sure you combine anything that can be combined. Okay, so like right now I have an 8x minus 6x. So an 8x minus 6x simply gives me a 2x. 2x minus 24 equals negative 18. Okay, and then now my problem has turned into the ones that we've been working on. Okay, so I'm going to add 24, add 24. So I get 2x equals, and then I find out a negative 18 plus 24 is going to give me 6. And then I divide by 2, and I find out my answer is x equals 3. Okay. All right, a few more problems. Just like before we had decimals, this is a problem where, yeah, we can actually end up with fractions. Okay, and there's a couple ways that you can solve these. I am going to do this one the traditional way to show you how to get rid of the 3/7. The next two problems, I'm going to show you how we can actually take that problem and we could actually eliminate the fractions. Okay, so it depends on how you want to do it. Sometimes it is best just to knock it and hit it and get out the 3/7 at the end. So just like we did before, when it was just 3x plus 9 equals 15, we got to get rid of everything that doesn't belong with the x. So those cancel. So I get 3/7 x equals 6. And the way that we're going to do that, if you remember, if I have 3/7, I want to end up with just 1, or just x. So what I'm going to do is I flip it and I multiply by its reciprocal. So I'm going to end up with 7 times 3 is 21, 7 times 3 is 21, 21 over 21 gives me 1. So in this case, and I'm going to change the color so you can see where the difference is at, I'm going to multiply this by 7/3. But remember, whatever I do to one side, I have to do the exact same thing to the other side. So what happens is these all cancel, and x equals, I can also do some canceling this way. This turns to a 1, this turns to a 2. Makes it a little easier. 2 times 7, then it's 14. You don't always have to cancel. You could have done 42 divided by 3, which would have also given you 14. Okay. All right. A couple more examples that we wanted to take a look at. On this one, 1/3 x plus a half equals 11/12. Sometimes when you're doing this, you can solve this the way we did before, where I'm going to subtract the 1/2, but now I've got 11/12 minus a half. And the problem that I run into then is I got to get common denominators. Turns into a lot of work. So one approach that you can take is you can find the least common denominator. In other words, what does 3, 2, and 12 all have in common? What's the first number in their list of multiples that they have in common? Well, if you remember, the list, the multiples of 3 are 3, 6, 9, 12, 15, 18, and the list actually keeps on going. And I just get those by 3 times 1, 3 times 2, 3 times 3, 3 times 4, and so on. The multiples of 2, 2, 4, 6, 8, 10, 12, and 14. And the same way, 2 times 1, 2 times 2, 2 times 3, 2 times 4. And 12, we're only going to do a few of these. So first one is 12, 24, and 36. Okay? And same way, 12 times 1, 12 times 2, 12 times 3. Okay? And you find out really fast that the first number, that they have in common